Boscovich was included in a group of 3 Roman mathematicians confided with the task of determining the causes of cracks in the dome of St. Peter's and suggesting remedies. Boscovich gave his viewpoints about the stability of the dome, which he shared with Jacquier and Lecerf in 2 expert analyses he wrote himself. The first was Parere, 1742, concluded with the proposal that the dome needed 3 iron tension rings. The second, entitled Riflessioni, was of apologetic nature, for it was written after secret and public disputations of the findings and proposals of the 3 Roman mathematicians. These writings about St. Peter's and its dome were Boscovich references for the commissioning of 2 more celebrated structural engineering assessments, in which he tested out the stability of the Imperial Library in Vienna and its dome in 1763, and the stability of the new pyramidal spire at the top of the dome of Milan Cathedral in 1765. The discussion around the interpretation and obviation of the damage to famed buildings centered around the issue of the authority of the Creator, who was entitled to make a final decision about the stability of building, artist or scientist. Boscovich was tweeted from the staff room of the Roman College that, I'm quoting, good Ghirlandaio thought his young pupil Buonarroti drawing and not mathematics. To the accusation that he wanted to outdo Michelangelo, which came from the pen of his fellow Jesuit Giovanni Battista Faure, Boscovich replied moderately, "In our writing there is not a word to offend that great man." End of quote. Boscovich only advocated a solution being found not via rule of thumb, on which artists and builders had previously exclusively relied, rather by theoretical explanation relying in scientific principle. Through Boscovich's writings on the cracks on the greatest Roman dome, in 1742, a new era started in the exact approach to building stability. Geodetic pursuits continued to stir Boscovich's inquisitive mind, from his first plan to set off to South America, so as to be able, close to the equator, to measure the length of the meridian degree to the extremely demanding expedition along the meridian of the St. Peter that passed through the tip of the dome of the Basilica of St. Peter. In 1750, Boscovich accepted the invitation of King João V of Portugal to travel to Brazil, but Boscovich's intention was changed by Cardinal Valenti, Secretary of State of the Holy See, obtaining an order from Benedict XIV for Boscovich to carry out, I'm quoting, an astronomical and geographical journey along the Rome to Rimini meridian in the Papal States. Having chosen Christopher Mayer to accompany him, Boscovich spent 2 academic years in this expedition from 1750 to 1752 with 2 main objectives: to measure the length of 2 degrees on the Roman meridian and to correct the map of the Papal States. The preparations were most thorough. It was Boscovich's task to choose a geodetic methodology, this triangulation, and astronomical instruments, there are his geodetic titles. The results by far exceeded their expectation and were published in the report De Literaria Expedizione der Pontificia per pontificiam editionem. In his assessment of the expedition's second objective, Boscovich proudly concluded, "The new map of the Papal States is more perfect than any map ever published to date. In the field of cartography, the prize fruit of their endeavors was the catalogue of the longitudes and latitudes of all the towns in the Papal States, with error up to 1 minute. On the basis of this table, Mayer charted the Nova Carta Geografica dello Stato Ecclesiastico." This is Florence example from the Florence University Library, and here is the example from the Royal Society Library in 3 sheets, shown on the exhibition. Rudyard Boscovich dealt with the hydraulic engineering assessment for a long period of the time, from Rome in 1751 to Paris in 1781, and this was a particularly prolific activity during his lecture in mathematics in Pavia and Milan. The first hydraulic engineering assessment was dedicated to the navigable channel of the Tiber, was done on the orders of Benedict XIV as a result of 2 expeditions to the flooded Tiber area in December 1750 and January 1751. The second is the expertise of Lucca, marshes in the border region between Lucca and Tuscany, and here is the expertise of Pontine marshes in 1764. Boscovich attempts to solve certain problems in astronomy, optics, and surveying resulted in his outstanding achievements in the theory, construction, and verification of astronomical, optical, geodetic, geophysical, and mathematical instruments. Boscovich constructed and applied a number of new instruments, while for some he proposed new manners of verification, and for some wrote excellent theoretical articles. This is the first spectrometer. This is the his proposal of new kind of telescope proposed for a celebrated experiment to establish the nature of light. The tube of telescope would be filled with water, and this is the final spectrometer with changeable glass prism. And finally, the last part of my lecture will be devoted to Boscovich's contribution to the humanities. About philosophy I told much, so I will limit my lecture to the literature and archaeology. Rudyard Boscovich's first appearance in public as a writer was in 1746, when he took part in the regular meetings of the Roman Accademia degli Arcadi, each Thursday on the hill Ianiculum. He introduced himself with 2 words, 5 pastoral dialogues,